Hello everyone and welcome once again to TMUA Simplified. Here in this section I am covering the solutions of chapter 7. So let's begin. So this was the first question of the exercise. It says that which of the following is the expression for the first derivative with respect to x of 3x square, right? 3x cube, sorry, 3x cube minus 2x square upon 5 root x. Let this be y and I have to find the derivative of this. Now simple. First of all, I can rearrange it a bit. So I can say it's 3 by 5. If I divide 3x cube by this, so I'll get 3 by 5 x to the power 3 minus half, which is 5 by 2, minus 2 by 5 x to the power 3 by 2 on dividing. So once I've divided, now I'll just differentiate. What is dy by dx? It will be 5 by 2 into 3 by 5 x to the power 5 by 2 minus 1. We know that x to the power n derivative is x to the power n minus 1, which I've covered. Right, so this will give me 5 by 2 minus 1 will be 3 by 2, minus 3 by 2 into 2 by 5, and x to the power 3 by 2 minus 1 will be half. So this is what I will get eventually. So final dy by dx will be 5 gets cancelled, so it gives me 3 by 2 x to the power 3 by 2 minus gets cancelled 3 by 5 x to the power half. Now on taking the LCM, I get 15 x to the power 3 by 2 minus 6 x to the power half upon 10. So let me check if we have this in the option. Okay, see what is to be observed here is in all the options in the denominator I have root of x. So the moment I will multiply and divide by root of x, I'm gonna get 15 x to the power 2 minus 6 x to the power 1, which is x only, and 10 root x. Now let's see whether this is there in the option or not. So yeah, this is there. So E is the right answer. A simple differentiation which we can apply. Right, now let's move on to the next one. Similar, but here we need to find the value. They're saying the function g is given by gx is 3 by x minus 2 upon x cube whole square. What is the value of g dash 1? This is what they are asking. Now, let me work on this a bit. So, gx, if I apply a minus b whole square, I'm going to get 9 by x square plus 4 by x to the power 6 minus 3 to the 12 x to the power 4. This is what I will get, which in return will give me 9x to the power minus 2 plus 4x to the power minus 6 minus 12x to the power minus 4. Now, if I differentiate using the same definition, so it will give me minus 2 will come here, so it will be minus 18x to the power minus 3 minus 24x to the power minus 7 and minus plus 48x to the power minus 5, which in return will be minus 18 by x cube minus 24 by x to the power 7 and plus 48 upon x to the power 5. Now what they are asking is g dash 1 derivative at 1 when x is 1. So it will give me minus 18 minus 24 plus 48, which will be 6. Right? So 6 is the right answer. Yes, D is the right answer. So simple. Yeah. Let's move on to the next. Again, similar, but here we need to find the second derivative. So second derivative, first of all, again, as in the previous question, we will first expand it, right, by using a minus b whole square. So kx will be 1 by x square plus 1 upon 9x to the power 4 minus 2 upon 3x to the power 3, which will further give me x to the power minus 2 plus x to the power minus 4 upon 9 minus 2x to the power minus 3 upon 3. Now, if I differentiate, suppose I find first derivative k dash x, it will give me minus 2x to the power minus 3 minus 4 by 9 x to the power minus 5 and plus 6 by 3 x to the power minus 4. This is the first derivative. So this is 2 now. Now let's find the second derivative. Similarly, it will give me 6x to the power minus 4 plus 20 by 9x to the power minus 6 and minus 8x to the power minus 5, and which will be 6 upon x to the power 4 plus 20 upon 9x to the power 6 minus 8 upon x to the power 5. Now I have to find the value at 1. It can be any, not just 1, it can be any, right? But 6 plus 20 by 9 minus 8. So it will give me 20 by 9 minus 2, which will be 2 by 9. 2 by 9 is the correct answer. Right? So let me look at the options. Yes, 2 by 9. D is the right answer. So very basic, three very basic questions which we have covered. Now let's move on to the next. Now this is based on tangents and normals, the application of derivatives. So they're saying a line is tangent to the curve y is equal to x square by 3. Y is equal to x square by 3 is the curve, equation of the curve, and there's a tangent to it where x is 2. Now it's like this, right? And tangent. So this point is the x coordinate of this is 2. So this also lies on the curve. So I can also find the y coordinate by putting it here. So it gives me 4 by 3. So the point that I have where the tangent is 2 comma 4 by 3. Right. Now I have to find the equation of the tangent. I know the point, but I need to know the slope. For slope, I'll differentiate as I covered in the theory video. Right. It is 4x by 3. X is given to me as 2. So it will give me, so this is 2x by 3. So if I put x as 2, it will give me 4 by 3. So the slope is again 4 by 3. So once I know the slope, now it's just boiled down to making the equation, which will be y minus 4 by 3, y minus y1 is equal to x minus x. So this further gives me 3y minus 4 by 3 is equal to 4x minus 8 by 3. This gets cancelled. So I get 4x minus 3y is equal to 4. This is the equation that I've got. But the question does not end here. They are saying the line cuts the x-axis at P and the y-axis at Q. So line cuts the x-axis at P, and so on x-axis y is 0. So I'll just put y as 0. So x is 1. I'm putting y as 0. 4x minus 0 is 4. So x is 1. So this point is on x-axis, which is 1 comma 0. Similarly, I can also find the point on the y-axis. So on y-axis x is 0. So if I put x as 0, so y will be minus 4 by 3. So I have a point 0 comma minus 4 by 3. And I have to find the distance between these 2 points, if I'm not wrong. Yeah, the length of PQ. So it's like the line is cutting like this. So I have to find the length of PQ. So PQ is length. So here I have to use coordinate geometry, distance formula, right? 1 minus distance will be under root of 1 minus 0 whole square, and then it will be plus the 0 minus minus 4 by 3 ka square. So it gives me distance is root of 1 plus 16 by 9. This will give me 25 by 9. The root of 25 by 9 will be 5 by 3. So 5 by 3 is the right answer. So let me check where exactly is in the option. Yes, D is the right answer. So this is how we can do this question. All TMU type questions are there, right? Right. Now let's move on to the next one. Now this covers for the normal, right? So it says that it says that um, a line drawn normal to the curve y is equal to 2x square. So as I say, this is the curve, this is the tangent, so normal is perpendicular to it. So this is what normal is, right? And I have to first find the equation of this normal, and then we have to again do it in the same way as we did in the previous question. The only difference here will be that at x equal to half, again this point x is half, so y I can find it, right? Y will be 2 into 1 by 4, which is again half. The point that I have is half comma half. Now it just boils down to finding the slope. So slope of the tangent is dy by dx, which is 4x, right? 4x and x is half. So 4 into half is 2. So the slope of the normal slope will be minus half. As we know, if two lines are perpendicular, then the product of their slopes is minus 1. So using that, I can find the slope of the normal. So once I find the slope of the normal, now I can find the equation of the normal, which is y minus half is equal to minus half x minus half. This is the equation of the normal. So it gives me y minus half is equal to minus x by 2 plus 1 by 4, which further gives me y plus x by 2 is equal to 1 by 4 plus half, right? Now, again, y plus x by 2, this becomes equal to 3 by 4. Now, when x is 0, y is 3 by 4. If I put x as 0, y is 3 by 4. And if I put y as 0, so x will be 3 by 2. Now, I have to find the distance using distance formula. So, it will be under root of 0 minus 3 by 2 square plus 3 by 4 minus 0 whole square. This is the distance or the length of PQ as in the previous case. So it will give me 9 by 4 plus 9 by 16 root, right? Which will be nothing but 4, root of 45 by 4. Root of 45 by 4, which is 3 root 5 by 4. 3 root 5 by 4 is the correct answer. So let me check the options. Yes, C is the right answer. So this is how we can do these questions, right? Let's move on to the next one. It says that the function 2 minus x upon x squared plus 1 is defined for all x. For how many integer values of x is the function decreasing? Now here we are covering the concept of increasing and decreasing. So as I covered in the theory video, for decreasing function, the first derivative should be less than 0. And they're talking about how many integer values of x is the function decreasing. So first, let me put it y is equal to 2 minus x upon x square plus 1. And I'm going to differentiate it. So it will be dy by dx is equal to, now here I'll be using quotient rule. So x square plus 1 into derivative of numerator, which is minus 1, minus 2 minus x into derivative of the denominator, which is 2x, upon x square plus 1 whole square. So this is the derivative. So finally what I will get is dy by dx is equal to minus x square minus 1 minus 4x plus 2x square upon x square plus 1 whole square. Now for decreasing, I need to put it less than 0. So since I can cross multiply, since this value is already positive, so I'll get x square minus 4x minus 1 minus 1 is less than 0. So if I find the roots will be uh, 4 plus minus under root b square, which is 16. 4 plus minus under root of 16 b square plus 4 upon 2. So this gives me uh, 2 plus minus and root of 20 is 2 root 5 root 5. This is what I'll get. So I know whenever we have say 2 minus root 5 and 2 plus root 5 as a root by method of interval, which I've covered in the quadratic equation video. So this is plus minus plus. So minus means negative where it is decreasing. So x will lie between 2 plus root 5 and greater than minus 2, sorry, 2 minus root 5. Now they are asking how many integer values of x satisfies this, right, for which it is decreasing. So I know approximately this value is less than 4 point something, and this value will be greater than 2 minus 2.1 will be minus 0.1. So greater than minus 0.1, we have integers which are 0, 1, 2, 3, 4. There are 5 integer values which lies in this range. So answer will be 5. E is the right answer, right? So this is how we have to do this question. So increasing, decreasing is okay, but you have to associate it with the language of the question which is asked here. Let's do the next one. It says that the function, this again, find the least positive integer value of x which the function is for which the function is increasing. Again, the same process. I will apply the y is equal to 4 minus x upon say 2x square plus 1. If I differentiate this using quotient rule, I'll get 2x square plus 1 into minus 1 and minus 4 minus x into differentiation of the denominator, which is 4x, upon 2x square plus 1 whole square. This will give me dy by dx, which is minus 2x square minus 1 minus 4, okay, minus 16x and plus 4x square, which will give me further upon as it is. This is. Now again for increasing, I'll put it greater than 0. So I'll get 2x square minus 16x minus 1 greater than 0. This is finally what I will get, because this will cross multiply and become 0. Since it's a positive value, I can safely cross multiply. So the roots of this will be minus b, which is 16 plus minus under root b square 256 plus 8 by 4. So this gives me the roots will be, if I, this is root of 264. 264 will be 64, right? So 264, if I divide by 4, 4, it will give me 66. Yes, 66, right? So it will be 16 plus minus 2 root 66 upon 4. So I know for increasing, it will be x will be greater than 4, or you can say 8, 8 plus root 66 by 2, or x will be less than 8 minus root 66 by 2. Now they are asking the least positive integer value. So which I wanna get from here. These are all negative values. 8 minus root of 66 will be negative. Less than negative will be negative. Now 8 plus root 66 is slightly more than 16, because root of 64 is 8. So 8 So 16 point something greater than 2. So x should be greater than 8 point something. So it has to be, the least value has to be 9. So 9 is the correct, least positive value. 9 is the correct answer. Okay, now let's move on to the next question. And it says that find the maximum value of the function fx equal to 3 upon x square minus 6x plus 10. Now, as you all know, we can maximize or minimize a polynomial um, x square minus 6x plus 10. It's easy to maximize or minimize, but it is in the denominator. So here we have to remember that this function will be maximized when the denominator is minimized, right? So any functions, if the numerator is constant, so I know on the when the denominator will take the minimum value, so the function here will take the maximum value. So if I look at this, so I have, right? So we have y is equal to 3 upon x square minus 6x plus 10. This is what the function is. So in order to maximize this function, we need to minimize this. So if I take, suppose this as, right, so if I find the first derivative, I will be getting dy by dx is equal to 2x minus 3, minus 6, sorry. So which will give me x equal, and if I put it first, if I put the first derivative as 0, so it will give me x equal to 3. Now at 3, definitely this is going to be minimized because it's a, cup-shaped parabola. So it will be the minimum value. Or you can find the second derivative, which is 2. And second derivative, since it's positive, so at x equal to 3, I'll get the minimum value. So I'll just put it, the y minimum will be, here this y, I mean this y will be minimum. If I put 9 minus 18 plus 10 will give me 1, right? So if I put 3 here, so I'm going to get 9. 6 is 18, 9 minus 18, which is minus 9 plus 10, which is 1. So this is eventually what I've got. So the maximum value of original function by original function, which is 1 upon this 3 upon this, will be 3 by 1. 3 is the answer. So the option, let me check. Yes, 3 becomes the right answer. So just find the first derivative, put it equal to 0. Get whatever the value of x that I'll get, it will be the point of maxima or minima. But since the second derivative is positive, so this will be a point of minima. And on putting this value in the expression, x square minus 6x plus 10, I'll get the minimum value, and which in this case will be 1. So the maximum value of the original function becomes 3 by 1, which is 3. Right. Let's move on to the next. Now it says that the least possible value of the gradient of the curve x minus d square into 3x plus d at the point where x is 2 as d varies is. It's very interesting. So they are minimizing the gradient. Gradient means the slope. So first I'll find the slope and then I will minimize the slope. So I'm not going to minimize this function because this is a general curve. But first I'll find the gradient, that is dy by dx. And if I apply the quotient rule, so I'll get x minus d square into 3 plus first as it is, derivative of the second, and then second as it is, derivative of the first, which will be, if I expand x minus d whole square, so I will be getting x square plus d square minus 2 dx. So the derivative of this will be 2x minus 2d. 2x minus 2d, right? So this is what I've got. So, so dy by dx, if I find it, it will give me x square plus d square minus 2 dx into 3, and then the multiplication of these two, this 3x plus d into 2x minus 2d. Right. So this is what I've got. Now they're asking the least value of this derivative. Suppose I say I'm representing it by slope s. So I'm putting dy by dx equal to s. So s will be, and x is 2. At x equal to 2, I'm going to get 4 plus d square, mm, right, minus 4d into 3 plus 3 to the 6 plus d and 2 to the 4 minus 2. So suppose, let me work on it a bit. So it will give me 12 plus 3d square minus 12d plus 24 minus 12d plus 4d minus 2d square. So which eventually will give me d square. This is minus minus plus, so it will be minus 20d, and plus 12 plus 24 will give me plus 36. This is S. Now I have to find the minimum value of the least value of the gradient. Right. So now I will be differentiating it again with respect to d. Right. So it will give me 2d minus 20. And finally, if I put it equal to 0, d will be 10. Again, it will be minimum because the second derivative will be 2. So at 10, this will give me the minimum value. So I'll put 10 here. So the minimum slope minimum will be, on putting 10, I'll get 100 minus 200 plus 36, which is minus 64. So minus 64 is the correct answer. I hope you understood. So first I differentiated the function to find the slope. Then I've substituted x equal to 2 because they're finding the least value of the gradient when x is 2. So on putting x equal to 2, I've got a equation of a slope, which is 12, which is d square minus 20d plus 36, this one. And then I differentiate it again to minimize it. So ds by d, right, with respect to d, I'm now differentiating. So it will give me 2d minus 20. Now if I put it equal to 0, so d is 10. So I'll put back 10 back into the expression and it will give me the minimum value of s. Right. I hope you understood this. Now it says that a curve C has equation y equal to fx equal to this, and P is real. The gradient of the normal of the to the curve C at the point where x is 2 is n. What is the greatest possible value of n if P varies? Again, a very similar kind of a question, right? So again, I'll say suppose y is equal to p cube minus 4p square x plus 2px square minus x cube. Now, if I find dy by dx, I'm going to get minus 4p square plus 4px, right, minus 3x square. Now, then they're saying, okay, the gradient of the normal, here they are talking about normal, not the gradient of the curve, or that is tangent. So for normal, I have to find the reciprocal of it with a minus sign because the product of the slope of tangent and normal is minus 1. So let's first put x as 2. So dy by dx at x equal to 2, I will be getting minus 4p square plus 8p minus 12. So the slope of the normal is, slope of the normal will be 1 upon 4p square minus 8p plus 12. So this, now I have to find the greatest, maximize it. So in order to maximize s, I have to minimize the denominator as we did in the earlier question. So suppose s is, suppose I take suppose random, say y is equal to 4p square minus 8p plus 12. So dy by dp will be 4p minus 8. If I put it equal to 0, so p will be 2. And this will give me the minimum value since the second derivative will again be positive. So if I put p as 2, I will be getting minimum value of y. So it will be 4 into 4, 16 minus 16 plus 12. So 12 is the minimum value. So answer becomes s minimum will become s maximum will become 1 upon 12. That's the right answer. Let me check the options, right? Just a minute. Okay. Sorry, this is a mistake. It's 8p minus 8. So 8p minus 8 will give me p equal to 1, right? So p is 1. So p is 1. So at 1, the value will be 4. Y minimum will be 4 minus 8 plus 12. So this will give me 8. So answer will be 1 upon 8. So 1 by 8 is the correct answer. Right. So this was a slight mistake which I made. Right. So now let's move on to the next question. It says find the complete set of values of the constant k for which the cubic equation has three distinct real solutions. Now it's a very interesting question. Right. Three distinct real solutions. Now for this, if I draw a graph of cubic, it will be like this. So graph is something which you should know. If it has three distinct solutions. Now it is imperative for us to understand that if it has to have three distinct solutions, then at the point of minima, the minimum value should be negative, and at the point of maxima, the maximum value should be positive. Then only it will have three distinct real solutions. Because the curve can also be like this, in which there will be only one real solution. But in that case, the minimum value will become positive. So it is, and it can also be like this, right? It can also be like this, that it is going through and it becomes this. Again, it will have only one, and here the maximum value will have negative. So the possibilities are different possibilities, but for three distinct real solutions or real solution of this cubic, I need to have a minimum value which is negative and the maximum value which is positive. So this is something which you have to understand very deeply, right? So now let me find the derivative. So 3x squared dy by dx is 3y square minus 12, 3x square minus 12x plus 9. This is the first derivative. Now, if I put it equal to 0, 3x square minus 12x plus 9 equal to 0, I will be getting x square minus 4x plus 3 equal to 0. So the roots of this will be 3 or 1. Now, if I find the second derivative will give me 6x minus 12. So at 3, I get the second derivative, which is 18 minus 12, 6, positive. So 3 becomes the point of minima. And at 1, it is negative. So 1 becomes the point of maximum. So what I have to understand now is at the point of the value of the function at 3 should become minimum. So my function is x cube minus 6x square, right, plus 9x plus k, right. So this is the value. Now I know if I put 3 in this, so it should become negative. So 3 cube is 27 minus 6 nines are 54 plus 9 threes are 27 plus k should be less than 0. So if it is less than 0, so it becomes k less than 0. So this is one condition. Second condition is if I put 1 in the function, so I will get 1 minus 6 plus 9 plus k. Now this should be greater than 0. At the point, maximum value should be positive. So k should be greater than, if I look at this, minus 4. So combining both these cases, my solution becomes k should be less than 0 but greater than minus 4. So this is the condition on k for three distinct real solutions. Very important question and very easy to understand if you do it through graph. If you first visualize through graph, right? Let's move on to the next. Now they say find the complete set of values of constant p for which the cubic equation is has only one real solution. Now I told you the graphs. I made the graphs in the last question also. So here also it will be either like this, right? It will have, you know, minimum value also positive, maximum value also positive. One case. Second case can be it's like this, but maximum is this. So both the minimum value and the maximum value are negative. So under these two cases, we have the roots of this cubic only one. So let's understand again. So I'll just differentiate. So y is equal to x cube minus 3x plus p. So if I find the first derivative dy by dx, I will be getting 3x square minus 3. So if I put it equal to 0, I'll get x equal to plus minus 1. So if I find the second derivative dy, right? So if I put 1, sorry, second derivative is 6x. If I put 1, it's positive. 1 is the point of minima. And if I put minus 1, it is negative. So minus 1 is the point of maxima. So this is what I have got. But I know two cases. First case is at 1 and minus 1, both the values should be positive. So if I put say 1, I will be getting 1 minus 3 plus p should be positive. And if I put minus 1, so minus 1 plus 3 plus p should also be positive. First case, this first graph, minimum and the maximum value both should be positive. So I'll get p greater than 2 and here I'll get p greater than minus 2. Now if I take intersection of these two, so I get p greater than 2. So this is the first condition. Second condition is both the values should be negative. So if I put negative, right, in the function, my function is this. So I'll get at 1 minus 3 plus p should be less than 0 and so it give me p less than 2 and minus 1 plus 3 plus p should also be less than 0. This gives me p less than minus 2. Now the intersection of these two will be p less than minus 2. So I have two cases. Either p should be greater than 2 or p should be less than minus 2. So if I look at my options, so D is the right answer, right? Again, so I have covered both the cases. There's one more case. Let's do that. This also. Find the complete set of values of the constant m for which the cubic equation this has three real roots with exactly two of them equal. Now, if I draw the graph of this, so it will be like this. It will be like this. So at the minimum value, right, or it should be like this also. It can be like this. So at one of the minimum or maximum value, the value should be 0. And so here if it is 0, so here it's positive. And here if it is negative, so here it's 0. So these are the two things that I need to cover. So again, first of all, I find the derivative, right, plus 9x plus m. So dy by dx will be 3x square minus 12x plus 9. If I put it equal to 0, so x square minus 4x plus 3 equal to 0, give me roots 3 or 1. Now again, second derivative will be 6x minus 12. So at 3, I get the point of maxima. Sorry, 3, I get the point of minima. And at 1, I get point of maxima. So at first case, at minimum value, value should become 0. So if I put 3 here, I get 27 minus 6, 6 times of, okay, 54 plus 27 plus m should be 0. So m should be 0. And at 1, in that case, should be the value should become positive, right? So at m, at 1, it should be positive, right? So if I put 1, so I'll get 1 minus 6 plus 9 plus m should be positive, right? Uh, but it will be positive, okay, right? So m should be greater than what? Minus 6 and 9 plus 1, it should be, m should be greater than minus 4. And 0 is greater than minus 4. So I'm getting one value of m as 0. Next case is when uh, at 1, in this case, the point of maximum, which is 1, the value should become 0. So in that case, 1 minus 6 plus 9 plus m should become 0. So m becomes equal to minus 4. So if I look at my options, so answer will be either m is 0 or m is minus 4. So there are two cases, right? And because they're asking the value of m, exact values. So m has two values, 0 or minus 4. Under these cases, only, two roots will be equal out of 3. Right? Okay, now let's move on to this question. It says that the line y equal to mx plus 4 where the slope is positive is, let's make a correction, it's tangent. Tangent to the curve y is equal to minus 8 minus x square at the point r comma s. What is the value of r? Right. Again, slope of tangent means the derivative only. So first I'll find dy by dx. Dy by dx will give me minus 2x and it is at r. So the slope becomes of the tangent dy by dx is equal to minus 2r. So the value of m is minus 2r. Now this point also lies on the curve as well as the tangent. So I'll say s is equal to m r plus 4 and s is equal to minus 8 minus r square, because this point lies on the tangent as well as the curve. It's somewhat like this. This is r comma s. Right. So now I'll just put the value of m. So s is equal to minus 2r square plus 4 and second is minus 8 minus r square. Now if I equate the s values, so minus 2r square plus 4 is equal to minus 8 minus r square. So r square will be equal to 12. So r is equal to plus minus 2 root 3. Now once I've got this, and this is in the beginning it says that the slope is positive and slope is minus 2r. So r has to be minus 2 root 3. So minus 2 root 3 is the correct answer. Okay, let's move on to this question now. It says find the shortest distance between the curve y is equal to x squared plus 3 and the line y equal to 3x minus 1. Now, just to make you visualize, I'm drawing the curve. So I know x square plus 3 curve will be like this. And if I plot this line, so for x 0, y is minus 1. And for y 0, x is 1 by 3. So the line looks like this. So this is what they're asking, the perpendicular distance. Now always remember, if we have a equation ax plus by plus c equal to 0, and if we have to find the perpendicular distance of a point, say x1, y1 from this line, so that distance is given by mod of ax1 plus by1 plus c under root of a square plus b square. This result will help you immensely in finding this distance, which I anyway in coordinate I will be covering, but very, very important result, right? Although there can be other processes also through which I can find the distance, but this saves a lot of time. So if you can remember this, it's good for you, right? Now, but for that I need to know the point. I know the line. Equation will be, I can write it in this similar manner as 3x minus y minus 1 equal to 0, but I don't know the point. So until and unless I know the point, I cannot find that distance. So to do that, I know that dy by dx here is 2x, right? And Since this is perpendicular and if I draw a tangent here, so these two lines becomes parallel. So if these two lines become parallel, right, so I can say slopes are equal. So 2x I can put it equal to the coefficient of x, which is 3. So x becomes 3 by 2. Now this point is also on the curve, so I can also find the y coordinate. So y is equal to x square plus 3. So it gives me 9 by 4 plus 3, which is 9 plus 12, 21 by 4. Once I've got this coordinate, then it's very easy for me to find this distance. The distance will be 3 into 3 by 2 mod of, right, minus y, which is minus 21 by 4. And then we have minus 1 upon, right, root of 3 square plus minus 1 square. So d will finally be, LCM is 4. So 9 to the 18 minus 21 minus 4 upon 4 root 10, which will give me mod of this, will give me 7, 7 upon 4 root 10. So this is the correct answer. If I multiply and divide by root 10, so answer will be 7 root 10 by 40. 7 root 10 by 40. Or yeah. So if I look at the option, okay, I think there's a slight mistake. This is a misprint. 7 root 10 by 40 is the correct answer, which is E. So this is how we can find it. It's very important. Now let's move on to this next. The curve D has an equation y is equal to x square plus cx plus 3, where c is greater than or equal to 0. Find the value of c that maximizes the distance between the origin and the stationary point of curve D. Stationary point again is the point of minima or maxima or point of inflection, but here they're talking about a curve which is cup shaped. It's like this. So here definitely this minimum value. And I have to find the maximum distance between this point and this. Right. So first I'll differentiate dy by dx. That will be 2x plus c. So if I put it equal to 0, x will be minus c by 2. Minus c by 2. And at minus c by 2, so value so obtained of this coordinate will be c square by 4 minus c square by 2 plus 3. So this gives me c square minus 2c square plus 12 by 4. So this will be 12 minus c square by 4. This is the point of stationary point. And I have to maximize the distance from the origin. So origin say from origin the distance will be using distance formula 0 comma 0. The distance will be under root of c square by 4 and plus 12 minus c square whole square by 16. Now in order to maximize d, I need to maximize the expression under the root. So let me take this expression as say y is equal to c square by 4 plus this will become 144 plus c to the power 4 minus 24c square upon 16, which will give me, if I take the LCM, so it will give me minus 20c square. This is 4c square minus 20, minus 20c square, or c to the power 4 minus 20c square plus 144. This is what I will get upon 16. Now if I find dy by dc, I will be getting 4c cube minus 40c. Right? This is the first derivative. So if I equate it equal to 0, so I'll get c 4c square common, c minus 40, no, 4c common, c square minus 10 equal to 0. So c will either be 0 or c will be plus minus root of 10. I have to maximize, so I need to check the second derivative. Second derivative will be uh, 12c square minus 40. So at 0, it will be negative, and at root 10, it will be positive. So 0 will be the point of maxima. So at c equal to 0, it get maximized. So answer is c equal to 0 is the answer. So just understand, I just find the stationary point from the origin using distance formula. I found the distance. Now, in order to maximize this distance, I need to maximize this, which I took it as y, and then I maximized by differentiating again. Right. Let's move on to the next. Now, px is a quadratic function in x. The graph of y is equal to px passes through the point 3, 19, and the turning quadratic function. So I can say px is y is equal to px is ax square plus bx plus c. This is how I can take a quadratic function. Passes through 3, 19. So 19 is equal to 3, 9a plus 3b plus c. This is one equation. And the turning point is minus 1, 3. So if I put minus 1 here um, in place of x and 3 is y, this turning point will also lie on the curve. Turning point again is the point of maxima or minima. So if I put it, so 3 is equal to minus uh, a minus b plus c. So this is what I have equation. So I have two equations and three unknowns. So I need to know one more relation. And how can I do that? So I know that the minimum point is minus 1, right? So if I subtract, so C will get, I can eliminate C, so it will be 8A plus 4B, right? So if I say, so this is what I have obtained. Now find the expression for Px. So I need to know one more relation between A and B, and this is something just tricky part, because I know the bottommost point will be minus, if I differentiate, I'll get 2ax plus b. So if I put it equal to 0, so minus b by 2a will become minus 1. But that again is there on the turning point. So if I say minus b by 2a is equal to minus 1, because if I differentiate and put it equal to 0, this is what I'll get. So b will be equal to 2a, right? So this is something which I can use here. So if I differentiate this dy by dx, I will be getting 2ax plus b. And if I put it equal to 0, so x will be minus b by 2a. So minus b by 2a is given to me as turning point as minus 1. So b becomes equal to 2a. The moment I get b equal to 2a, so I get 16a equal to 16. So a becomes equal to 1. If a is 1, then b is 2a, so b becomes 2. And if p becomes 2 and I put it in the equation, so 3 is equal to 1 minus 3 is equal to 1 minus 2 plus c. So c will be 4. So if then the equation will be a is 1, b is 2 and c is 4. So I'll just put it x square plus 2b plus 2x plus 4. Right? So it's x square plus 2x plus 4. Just a minute. Yes. Yeah, just a correction. It's plus 2x. Or a is 1, I hope. Yes. 8a, if I subtract b minus b by 2a is minus 1. Yes. A is 1, b is 2. So I think it's plus. Just a correction. So C is the correct answer. It's plus 2x plus 4. Right. So this is how we can do this question. Okay. Next. The function f is defined for all real values, real x, as fx is q minus x into x plus 3. Find the complete set of values of q for which the maximum value of fx is less than 6. Again, So first I'll multiply. So fx gives me qx plus 3q minus x square minus 3x. So which will finally be minus x square plus x q minus 3 plus 3q. Now if I differentiate, I'm going to get minus 2x plus q minus 3. This is the first derivative f dash x. Okay, now if I put it equal to 0, at this I will be getting the maximum value because the second derivative will be negative. So it gives me x equal to q minus 3 by 2. Q minus 3 by 2. So if I put it here in this equation, so I will be getting minus of q minus 3 by 2 whole square and plus q minus 3 whole square by 2 plus 3q. Okay. So the value of y so obtained here would be minus q minus 3 by 2 whole square plus q minus 3 into x is q minus 3 whole square by 2 plus 3q. So it will be q minus 3 whole square by 4 plus q minus 3 whole square by 2 plus 3q. So if I take LCM, so it becomes q minus 3 whole square because 2 minus 1 will become this only plus 3q or plus 3 4 so 12q by 4. Now, this should be, they're saying maximum value should be less than 6. So this should be less than 6. So what I will get finally is q square plus 9 minus 6q plus 12q should be less than 24. So this gives me q square plus 6q and minus 15 is less than 0. So if I find the roots, so roots of this will be it will be irrational. So I have to find it. So it will be minus 6 plus minus under root b square, which is 36 plus 60 upon 2. So q will lie between minus 3 plus uh, 16, 6, 16, 16, 4 will outside 4, 2 root 6 and greater than minus 3 minus 2 root 6. So this is what the answer will be. The q is less than minus 3 plus 2 root 6 but greater than minus 3 minus 2 root 6. Right? So let's check the option. Yes, so B is the right answer. So these are important questions on TMUA, right? I hope you have done it very well, right? I'll come again with the next video, which will be on integration. Till then, take care.